Okay, hello everyone. So what I want to do in this video is I want to go ahead and graph a parabola. Now, I know I've done a few of these in the past, and I've also done them in my short videos, but this is for those of you who really need help understanding, how to do this. Now, we have f of x equals negative the quantity, and it is x minus 3 squared plus 1. So this is what we call vertex form, right? And I will rewrite the vertex form of a parabola, or the vertex form of a quadratic. So the vertex form goes something like this. So we have f of x, and then we have our value of a, and then it goes times x minus, and then we have h, and then quantity squared, plus, and then we have our k value, right? Now, basically, so a just means if the parabola opens up or down. Remember that we have two types of shapes for parabola. We have a one that looks like this, and then another one that looks like this, right? So when it goes up like this, that means that a is greater than 0, and when it goes down like this, that means a is less than 0, right? And the vertex is always the middle point of your parabola. So the vertex is always going to be hk, so in reality this point here is h comma, and then it would be k, like this, right? Same thing for this one. It would be h oops, it would be h comma k, right? And that would be the vertex of the parabola, right? And that's just either the highest point or the lowest point of the curve. Think of it kind of like a hill or a cusp, right? So looking at this, we have, if I rewrite it up here, f of x equals a negative the quantity x minus 3 squared plus 1. I'm going to go ahead and kind of, simplify this a little bit better. So this will be, basically this whole equation, or function rather, can be rewritten like this. F of x equals, and we're going to put, and again, we're going to label it so that, we're going to color code it so that you guys can know what I'm talking about. So it's going to be negative 1 times x minus, and then we have a 3 right here. So like this, and then squared plus, and then we have a 1, right, like this. So basically we have something like this, right? And we know that a is equal to negative 1, right? And then we also know that our h value is equal to 3, and our k value is equal to 1. So we know that the vertex of this parabola is going to be hk, which is really just 3, 1, right? And we can go ahead and plot the point 3, 1. So 3, 1 is right here. So this is our vertex, right? Now our axis of symmetry, when you think of axis of symmetry in a parabola, what you always want to know about, if you have any kind of parabola, it really doesn't matter how it's shaped, but any parabola, this x equals h value is your axis of symmetry. And right here would be like h comma k. But the axis of symmetry just means that it is the x value of your vertex. So here, the axis of symmetry is x equals 3, right? So we can label that. So obviously we have something, and this is just for reference. I mean, I don't know if at the end they make you label your axis of symmetry or not. But this is kind of, it really helps when, whenever you're graphing these, because that way you know how to reflect your points at the end, right? Or what line to reflect your points in. So basically here we have 3, 1, right? And now we have to find 2 points where, 2 other points that can satisfy this function, right? So if we go on the right-hand side, so again, we're going to rewrite our function f of x equals negative the quantity x minus 3 squared plus 1, right? And then we know that our parabola is going to open down. And how do we know that? We know that because a is less than 0. We said a is equal to -1, and -1 is less than 0, so it's going to be opening down like this, right? That's how we know it's going to be a downwards parabola. So then we have, then if we do f of 4, for example, we can say that f of 4 is really, and let me actually color code, f of 4 is going to be equal to negative the quantity, and it's going to be 4 minus 3 squared plus 1. So it's equal to negative the quantity 1 quantity squared plus 1. And that's just equal to -1 plus 1, which is 0. So when x equals 4, y equals 0. So this can be another point, and we can label it, right, for 0. I'm going to go ahead and move, let me, like this, and then like this right here. So then let's do x equals 5. When x equals 5, y is going to be negative the quantity, and we have, so again, if we want to color code, we have f of 5 equals negative the quantity 5 minus 3 squared plus 1. So it's going to be negative the quantity 2 squared plus 1, which is -4 plus 1, which is -3. So when x equals 5, y is equal to -3, right? So you have something like this. And then when x equals negative, so when x equals 6, excuse me, so we have, so this point is obviously -3, so can, and you don't have to label your points. This is just to show you guys, just for reference, how exactly I'm doing this. So when x equals 6, we can do one more. When x equals 6, we can say that we have negative the quantity, and again, up here is our function, right? This is our function. So we have negative the quantity, and it's going to be 6 minus 3 squared plus 1, right? And this is going to be negative the quantity 3 squared plus 1, which is negative 9 plus 1, which is really just negative 8, right? And so it would be 6, negative 8 right here. So now, again, like I said, we're going to reflect our points. So think of this as kind of like a mirror, right? You're going to go to the left. So here we have this point here. We're going to go 1, 1. So here's going to be our other point. And then here, to get from this point to the axis of symmetry, we go 1, 2, 3. So, or actually, I'm sorry. It goes 1, 2, and then we go 1, 2 again. So it's going to be right here. So really what I did was this, 1, 2, and then I go 1, 2, like that, right? And then over here, when x equals 6, I'm going to go 1, 2, 3, and then I'm going to go again 1, 2, 3. So right here. Okay. And now you can draw your smooth curve, so it doesn't have to be perfect, but so really it's going to be something like this. And again, it doesn't have to be perfect, as long as it's pretty accurate, you know. And again, the vertex is right here, so this is a vertex. So right there is a vertex, 3, 1, and then the axis of symmetry is x equals 3. So this is your axis of symmetry, right? And that is how you would graph this equation for this parabola, right? Okay, so that is it, guys, for this video. If you have any questions, please let me know. I know it was a little bit of a long video, but I hope that helped. So yeah, if anybody has any questions, please let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.